In our previous video, we have been showing how to manipulate and juggle processes from the foreground to the background, etc. But we have been referring to them as jobs using their job ID. So we saw that you can have, for example, an editor like something.txt. There we go. Gedit something.txt working in the background. Okay, nice. And you can see its job ID here. Right. You can see it also when you just start the process in the background. It's displayed by the shell. But in addition, we have also the concept of process ID here, PID, that we mentioned, but we didn't really do anything with that. So let's start this video by talking about different options that we have to monitor what's going on, what's running on our system. So we already explored the jobs command. That gives us an idea of what kind of process, okay, we started from this particular bash session in this particular terminal. But we might want to look at actually what's running on our system as a whole, right? No matter what terminal we started again. If we have like 10 terminals open on multiple desktop, virtual desktop on our workstation, we don't want to keep track of where we started what when we are searching for a background process that we started. So to do that, we have the PS command. The PS command by default is going to show you only things that are relevant to the user that you are logged as right now. So I'm logged in as user Tux. So these are all things that user Tux is currently running on the system. So you can see that I'm not doing much actually, but I'm running a bash shell here. I'm running the PS command in the bash shell, and I'm running gedit. Okay. As a matter of fact, these are processes related to this session here, this bash session. Okay. But there are many different options available in the PS command. Okay, so you can take a look at the manual page for PS and explore them on your own. But I'm just going to show you some interesting one. PS-A for all UX. Oh, -AUX is going to. -AUX is the most commonly used option. It's going to allow you to get an idea of everything that's running on your system. Okay, so you can see here the first column. If I scroll back enough, there we go. The first column is a user name. It's one of the options allows us to see a user in a human readable format. Okay, so the user root is running a lot of processes obviously on the machine, that's the system. It tells you the PID of that specific process. So generally low PID numbers are for system process that were started when your machine booted. Okay, it tells you some indication about when it started, some time it has been running, etc., and the command that was issued to start it. So you can see a lot of stuff here belongs to the root user. Then we have some users that are created specifically to run some specific services, okay, like the syslog service or the Hawaii user. You can see also that I have my user Tux running a bunch of process, and that's why I wanted to show you not only the PS default version, but also the PS that has option to show everything, because my desktop right now, my entire desktop environment is running under the username Tux, right? So you see all of those things, including the VirtualBox client, as host, guest extension. All of this is running actually as a process in the background, okay, independently of my terminal session. But when I type just PS, okay, it gives you the impression maybe that I'm not running much, but this is just what I started in this bash session. Okay, so more interestingly, we can use another utility called top. Okay, and this one is running in the foreground right now, and this top utility is going to give me a lot of information about the state of my system, how much memory is used, how much memory is available, and so on and so forth. But it also constantly update live a list of the different processes working on my system. So all user, together, kind of like the same thing we get when we do PS-AUX, except that it's constantly updated, and by default it's going to be ranked by percentage of CPU utilization. So it's going to show you pretty much the process or processes that are using the most amount of CPU first and then go decreasing, okay? So for example here, Xorg, that's my X server, that's my windowing environment, the NOM terminal, Compiz, this is also a process related to the desktop management that allows for animation of windows and stuff like that. So you see that those are the things that are using the most resource of my system, okay? And then you see the top itself is using pretty decent amount of resource and so on and so forth. And this is updated by default every second. Now, if you look at the manual page for the top utility, you're going to find a bunch of options and even shortcut keys that you can use while the top is running to reorder, resort the list, operate on processes, etc. Of interest to us for this video is that just like PS and PS-AUX, we get here for the processes a little bit of information that's really interesting, which is their PID. And their PID can be used as a handle, as a name pretty much, to interact with those processes. So let me get out of top right now, and I do so by just pressing the key Q for quit, okay? Let me get out of top and let's take a look at that ID of process ID, PID, okay, and what I can do with it. So I've already illustrated what I can do when I can refer to a job with the FG and BG commands, okay, so I can bring a job back in the background, foreground, etc. Now, I would like to introduce another command. This command name is unfortunate. It's called kill. So a lot of people, when they first learn to use the Linux command line interface and manage processes with it, they assume that the kill command is only good for one thing, which is killing a process. And it's okay because it's an easy confusion to make. If I type kill %1, so I use the same % syntax here that I used to refer to job number. If I type kill %1, it just killed that gedit window, okay? It's no longer on my desktop, and if I type jobs, you can see that it's gone, okay? It just terminated and it's no longer running in the background. So that's the source of the confusion, is that people try this little demonstration I did here, and they come to the conclusion that kill is only good at one thing, which is terminating processes. That's not true. We're going to come back on that, okay? But for now, before we get there, let me illustrate something else. We can use that syntax, %1 that we used before, but if I am editing a file like that with gedit in the background, okay, and I want to actually use again the kill command, I do not have to actually necessarily know its job number. I could go from any terminal, any bash session on my current workstation, and if I just enter the PID that was given to me here, same thing, okay? So I try to look, it's terminated, it's no longer running on my desktop. So I can use kill either with the job number, if I know it, or the PID. Right now, the only way to get the PID was, to look at what is displayed when I start my command. Well, I could use also PS. I could use PS or top, okay? So top, generally, you're not going to really use that except if you want to keep an eye on your system, but you can very well use PS and say, okay, this is the PID for my gedit working in the background, so I'm going to use the kill command on that PID, and this is going to result in, and if I do PS again, there we go. The job was terminated, okay, the process was terminated. It's no longer showing when I do a PS, okay, or if I was doing a top. So I have a way here to literally kill processes, okay? But really the kill command is not there to actually kill processes. It's not there to only kill processes, I should say. So let me show you what I mean by that. If you use the kill command here and you use the option -L, it's going to give you a list of things that are called signal names, okay? So in this list there are 64 different signals, and you can use another option -L uppercase. Actually no, sorry, that option has been deprecated, but -L lowercase is listing for you all the signals that are available to the kill command. So what are signals? Signals are a way to communicate between processes on the Linux operating system. So one process, for let's say, for example, the process that is executing your bash interpreter, can send a signal to another process. For example, the process that is running in the background that you started from that same bash session. Okay, so let's go ahead again and start a gedit on a bogus file. Okay, so we have this process running right now in the background on our desktop. So we can use a kill command to send specific signals out of that list of 64 signals to that process. So by default, when you do kill and you specify a PID like 8981, the default behavior of the kill command, and which is what earned it its name, okay, is to send a specific signal called term. Okay, term for terminate. All right, so the signal is listed in this list somewhere as sig term. There we go. It has number 15. So this is just the arbitrary convention. Okay, so signal number 15 on the Linux system is named sig term, also often abbreviated as term, and it means the signal terminate. So if I write kill 8981, there we go. I just killed the process that was running in the background. Okay, so I can use this default behavior of the kill command, but I can also choose to specify actually which of the signals I want to send, and if I do so, then I can obtain different behaviors. For example, most of the programs to which most of the processes to which you are going to send a term signal are going to terminate. But the term signal is a way to ask politely the process to terminate, which means that it's going to close the files that are open, that it opened. It's going to save your data. It's going to do everything to a perfect, proper shutdown. But what happens if your process has a bug? What happens if you are running gedit and suddenly gedit is crashing? It's not responding anything. You need to shut it down. Well, sending the term signal is not going to help you because it's politely asking the process to shut down, but since the process is not responsive anymore, then it's not going to be able to respond to a signal and shut down properly. So this is where we can start using over signal, with a kill command. For example, the sig kill signal, which is over here, okay, number 9, is a signal that allows us to tell the process shut down, but if the process is not responding, the OS will shut it down for us. So it's kind of a brutal shutdown of the process. So you should avoid that, okay? You should avoid shutting down your processes by sending them a signal to start off with if you can, For example, if you're using gedit, just click that button, close the window, that's better. Go to the menu, select file, quit option, do a Control Q. Perfect. All of those are proper way to terminate gedit, okay? For some reason you want to send it a term signal, fine, this is okay. But if you send it a kill signal, this is even more brutal, okay? So just keep that in mind. You might lose some information. For example, the last edits that you were doing in gedit might be lost if you send the kill signal. But if I do this, if I send the kill signal here, so let me move here so that you can see the window disappearing. Well, then it's going to obviously, it's going to obviously tell me that I'm reusing the last command line I typed, so it's not the same process number. But if I give the correct PID actually for the last gedit that I started, it's going to kill it indeed and make it go away more brutally, okay? So we have a bunch of different signals like that we can use. So I'm going to talk only about 4 of them, but you know that you can get the full list here and then research it in the manual if you need. So let's illustrate. So we already illustrated term and kill. So I can illustrate the default behavior of the kill command, okay, by starting another process in the background, another gedit process, and then saying that I want to send the term signal to 9057, which is the PID of that process. Okay, and that's what would happen if I just would have typed, 9057 like that by default. So this default signal that sent is term. I can have a more brutal version of term called kill that is sent by the kill command itself. And the two other signals I'm going to mention are stop and count. And stop stands for, well, stop, and count for continue. Okay, so if I just do -L here, you're going to find the signals in this list under the name sig count and sig stop. So here's sig count, here's sig stop, here's their number. Okay, so if I have something running like this in the background, so I'm always using the gedit as an example of a process, I can actually say kill -stop. So that I name the signal I want to send to that process, and I say 9078. All right. So now, if I do a jobs, if I do a PS, I can see that gedit is still working in the background, but if I try to click, on the buttons or do anything, it's not responding. That's exactly what I've done in previous videos when I was running gedit in the foreground, and suddenly I use Ctrl-Z. So the Ctrl-Z shortcut for a foreground process running in your bash session is the same thing than sending the signal stop with a kill command from anywhere in the system, another bash session, another terminal, or if your process is running in the background, sending it from the same terminal where you started it, it doesn't matter. Okay, it's just the same way to freeze the execution of the process. Okay, to put it in a state that is referred to as stopped. Okay, and nothing works here, nothing is going on. And then I can use the kill command, but this time change the signal that I send from stop to count, that stands for, as you can guess, continue, and then my editor should be responsive. There we go. It is actually resuming execution in the background. Okay, so four different signals. There are many more. Okay, 64, but it's difficult to talk about the meaning of those signals in the context of an introduction to Linux, like this one. This is something that we would explore much more thoroughly in an operating system course, typically, where we study, ways to establish communication between processes, and we study how the operating system handles those communication. But for now, at least with those four, you can do pretty much everything we're doing with shortcut like Ctrl-Z, Ctrl-C, the foreground, background commands that we studied in previous videos. You can do all of that, with the kill command from any terminal pretty much on your system. Okay. Last thing that I'm going to specify, there are different syntaxes that you can use when you use the kill command to specify the signal itself. So we have been using continue and stop. So continue is 18, okay, stop is 19. So if I wanted, I could either, like, for example, do like this, -stop, okay, and then -continue. So this is what I've been doing in my previous example. Okay, you can see here I can type again in my editor, but instead of using the -stop and -continue syntax, I could do things like -s, and some of the syntax can be maybe deprecated, so we're going to try them out, and I'll point out which one are still valid and which one are deprecated. So I could do -s for signal stop 9078, so that one seems to be working. -s count 9078, that one seems to be working. Okay, so instead of just specifying dash and the name of the signal, you can do -s followed by the name of the signal, but you can also use their number. Okay, so we saw that if I go back to the list, there we go. 18 was continue and 19 was stop. Okay, so let's use that alternate syntax that is first stop. So I'm going to stop by sending signal 19, and then I'm going to resume execution by sending signal 18. So you can use their name, you can use their signal, and you can use also with or without the -s option. So the same way you could use the signal name directly, And oop, the syntax is not going to work just right, because I typed 19 instead of -19. My apologies. So I tried to kill a process that didn't belong to me, so that's why I got operation not permitted, and then I completely killed my process in the background, because that was the default behavior of kill. When you don't specify a signal name, it just uses term. So let me restart. Little mistake here, but mistake we can learn from, so that's all good. Let me restart here another GAD. So 9159 is a PID, and now I can do kill -19 instead of just using the number. I need to do dash and the number. Okay, so -19 is going to I used the wrong PID. 91. So that's an error from which we don't learn a lot. Sorry about that. But the other one was more interesting. So kill -9159, and now I have a process here that is not responsive anymore. It's frozen. And then if I say now send signal 18, so 18 is a continuous signal. There we go. It's there, but now it's responsive. I can type, I can do things with it. Okay, so different syntax is not a big deal, but it just means that depending on what documentation you are reading, what tutorial you are following, you might see people use a signal name or use the -s signal name or the -s signal number or the dash and signal number directly appended to it. Okay, so these are things that you should be able to decrypt now that we got an overview of the syntax and so on.